I am Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about network, the programming and management as a subject, in which the topic are mutex and conditional variables. Mutex is nothing but a mutual exclusion. Mutual exclusion can be done based on the condition. Here, mutex and a conditional variable generally, so in the context of advanced the socket and the programming, mutex, that means mutual exclusion, and conditional variables are so very crucial for managing the concurrency and ensuring the thread safe for operations. Here is mutual exclusion. Mutual exclusion means the resources can be shareable by the only one thread. Only one other thread. The mutual exclusion can be implemented by using the critical region. By using critical section or critical region. Here is in a critical section, only this the critical section, it is a executable area. The process can be executed within this the critical section. Here is only one process can be executed at a time. This means these are the critical section which allowing only one process at a time. Only one process at a time. So this is about the critical section. So this is the critical section. With the help of this, the critical section, now we can implement the mutual exclusion. Here the condition variables. Generally in a advanced socket the programming, generally we can use the two conditional variables. The two conditional variables are, one is a weight conditional variable, that means x dot weight and x dot signal. X dot signal. These two conditional, with these two conditional variable, now the socket the programming, advanced the socket programming can be done. So these two are the very important in for managing the concurrency. For managing concurrency. So concurrency means, that means more than one processes can be performed at a time. Here is the in parallelism also now you can perform the more than one other tasks at a time. The main the difference between the parallelism and concurrency, that means two, for example, two threads, if we take the thread 1 and thread 2. So these two threads can be perform the operation. These two threads can be perform the operations on a single CPU. At a time, that means if you perform the operations at a time in a single CPU, we can call it as the concurrency. That means here at a time, so the CPU on a processor performing these two tasks at a time on a processor, so it's not possible. That's why now these in a concurrency, the concept what we'll do. So first these the process can be allocated to these are the CPU. So after completing the task, after completing this the thread, the transaction, this is the execution, now we can allocate the transaction to this other CPU. This is the concurrency. And the parallelism, in a parallelism means here two other CPUs and the two other processors can be used. So it is a CPU 1 and CPU 2. CPU 1 and CPU 2. In CPU 1, processor 1, that means P1 can be executed in a CPU 1 and the processor 2, P2 can be executed in a CPU 2. So it is a parallelism. At a time can be other performed. But here at a time in concurrency also we are performing the at a time, but here the tasks can be performed sequentially. After completing the one task, now we are performing another other task. But here at a time now both the tasks can be performed. So that is a managing the concurrency that can be managed. These are the concurrency mechanism. These are the concurrency. The concept can be managed by using the mutex. That is a mutual exclusion. For that now we are utilizing the critical region or the critical section along with the condition variables. Here is these are the mutual exclusion. Mutual exclusions generally which is used to ensuring that only one thread or one process can be accessed for a sharing the resource or a critical section of the code at a time. Here is, so this is the shared resources. This resource is a shared other resources. So mutual exclusion means it is a critical section or the critical region which allow only one thread or only one processor for sharing the resources. Here is now if it is allow these are the thread now which is make it into waiting state to this state. That means here wait once whenever the waiting is released, then we can allocate this thread for into the critical other region. In this other critical region, once if it is released the wait, then this other process can be executed within this critical region. So this is about the mutex. This is about the mutual exclusion and the condition variables. The brief summarization and mutual exclusion. If you take these the mutual exclusions, so main purpose of this mutual exclusion is mutex mutual exclusion objects. Generally, these are used to preventing the multi-thread processing. To prevent the multi-thread. That means here multiple thread at a time. Now we can't other process from accessing a shared resource simultaneously, which ensuring the data consistency. That means now multi-threading concept, multi-other processing cannot be, we can't other do with help of with the mutex. That's why now which is the controlling the multi-threading. Mutex now this with the help of this the critical section or critical section code. Now we can prevent the multiple task performance. Generally for that now we are using for preventing multi-threading. Generally we are using the common operations are lock operation and unlock operations and try-lock operation. These operations can be utilized. That is a data, so which ensures the, with this one now we can ensure the data is a consistent. The data is a consistent means here once if it is stored in a database, here once if the data is the store, data is a store in a database. Data is stored in a database. If it is a consistent, we can say by using this the data, whatever the data we have stored in a database, with help of this the data, now we can perform. We can perform the multiple other tasks. Now we can make the decision. We can make the decision on a database. Whatever the database now we are considering. For that other database now we can take the decisions and performing the operations. So this is the data of consistency. These operations can be performed. It can be implemented by performing these operations. One is a lock operation, another one is a unlock operation and try to lock operation. So lock operation means here once the critical section, once if it is the critical section now which is allotted, which allocating the task. Once if it is allocate the task, so into this the critical section now which is a lock up to to completing the task. After completing the task, after completing the job, now these are the critical section now which is unlock, that other job. Unlocking, that means here which is giving the chance to another job one by one. The sequentially the critical section now which is executing the other process sequentially, not at a time. At a time which can't perform the task, not at a time, only which can perform the task sequentially. And trying log. Trying log means here now always when it is a trying log, if any one process is in a critical region, within this the critical region, always now which is trying to for log. If there is no process in a critical region, now it will be unlock and giving the other chance to the another other process and completing the other task. These are locking, unlocking, and trying locking the operations. Now generally we can use in a mutual exclusion performance. Here is usage in a code. Generally these are the mutual exclusion, that is which is initialization. First is a initialization. Here mutual exclusions which need to be the initialized before using. That means before using of the transactions, now we have to first initialize the mutual exclusion condition. Once if you initialize the mutual exclusion and the condition to the critical region, that at the critical region now which is allowing only the one process at a time. Here is often with the pthread mutex initialization. Now in a C language or C++ language, now generally we can use the pthread mutex initialization method. By using this the method now, by using this method we can initialize the process to the critical section. Pthread means here POSIX thread mutual exclusion initialization. POSIX means so it is a here with help of this pthread mutex line, that is a pthread. The meaning of the pthread is a portable operating system interface. That is now we can say it as a POSIX. POSIX is a portable operating system interface. With help of this one now we can initialize to the critical other section to mutex. And a locking mechanism. Locking mechanism here generally a thread. Here is a thread or a process locks the mutex. Locks to the mutex means now critical section, which is locking the critical section. How can locking the critical section means so portable thread interface, portable thread operating system interface lock method, mutex lock method before accessing the shared resources. Here that means once the resources is shared by the critical region or critical section, immediately which is lock. Here for that now we are using the pthread mutex lock the method. So by using this the lock the method, now we can lock the critical other section and processing the threads or processing the jobs. And unlocking generally when we can unlock here is if whatever the items now we have stored or whatever the threads now you are performed within this the critical region, once the task is completed, now we can perform the unlock operation. Here if it is the task is not completed now, just which is make in locking condition only. Here is unlocking. Unlocking means here after the resources is used, the thread unlocks. Unlocks the mutex using the pthread mutex unlock methods. Here condition variables. Now if you see the condition variables. The condition variables generally we are using two types of these condition variables. Now we can use one is a weight x dot weight the condition variable here, and x dot the signal. Here these two are the condition variables now, x and y. These two are the other variables. So and these can be performed. These two condition variables can be performed by using these operations, that is x dot weight operation and x dot signal operations. Here is the condition variables are used for signaling between the threads. Now between the threads which will be executed in a critical region. Now which is allowing one thread to notify the another thread about the changes in a thread state of the shared resources. That means the operations, common operations now we can use. So wait and signal and broadcast, these are the common operations can be utilized. The condition variables are x comma y is a condition variable. These two operations are allowed. That means on a condition variable. These are the two other condition variables. Now we are allowing the two operation. One is a wait. When this operation now we are making it as a wait here. Already if anyone the process in a critical region or in a critical section, now we can apply the waiting process. X dot waiting process. X dot waiting process means here already one process is already executing in this the critical section. Already one job now the processing we are performing under running process. If it is under running process now, simply we can make it as the critical section as a waiting state, that is the x dot wait. So this is a process that invokes the operations is suspended until x dot signals. X dot the signals here up to getting that signal. Now it will be suspended. Once if the task is completed or process is completed, now so in this the critical region, so it will be unlock the critical region. Now it is unlock the critical region. Once if it is unlock the critical region, now we can allow the another other transactions to execute within this critical region. So here for unlocking signaling, now for unlocking signaling up to that, now another other process or another thread now which is the waiting, which is make into the waiting state up to getting the unlock. Here is S dot signaling, which resumes one of the other process. Signaling, that means if any one process, that is a process 1 or other process 2, any one of the process now which is resuming any one of the other process. That means which invoked on a whatever the other process is invoked on a waiting state. Suppose if the P1 process is invoked in a waiting state now, so X dot or the signaling will be resumed on a P1 other process. Suppose if the P2 process is on a waiting state now, it will be resumed. Invoke the resumed on a the signaling is it will be the invoked on a P2 process. That means if x dot wait on the variables, then it has no other effect on the variables. Usage in a code. Usage in a code here, generally we can utilize the initialization and waiting and the signaling, the processing can be used. Here is in a initialization, the critical section can be initialized. The critical section can be initialized to variables. So that is the condition variables. The condition variables are initialized using the P thread the condition unit. That is a portable operating system the interface. That can be this portable operating the system interface now, which will make the initialization to the variable based on the other conditions. That is here with this the condition now the system will be the portable. That means whatever the variables, whatever the other processes now you are using in under this the critical other section, so that other variables with or without the modifications we can utilize in any operating system. So that is a waiting. Waiting means here a thread can wait on a conditional variable. So using the pthread condition wait, so which can automatically unlock the associated other mutex. So associated other mutex, that means here when it is associated with the mutual other exclusion means here whenever it is unlock the process from the critical other section. So this is a critical section. This the critical section, it is a executable environment. Executable environment. So executable environment. So once if the process is completed, so that can be unlocked. And unlocked means once if it is unlocked, which is associated with the mutual exclusion, which is associated with the mutual exclusion, which is associated with mutual other exclusion and blocks the thread until the condition is signaled. Here is the signaling. Signaling means here now another thread can be signal the condition variable using the portable operating system thread the condition the signals or pthread condition broadcast the method. Now we are using this pthread broadcast the method to wake up one or more waiting threads. Here is the example of the scenario in a socket. The programming is in an advanced socket programming. The synchronization of the primitives can be used to managing the connections, and data transfers between the threads safely. Here is the mutex might be used to protect a shared list of active connections. That means next the conditional variables. Conditional variables might be used to signal a worker thread. To signaling the worker thread means now a new connection is added to the list. Here this is about the conditional other variable that can be used to signaling the critical section or to signaling the other threads or to signaling the processing thread for the execution and for completing the other task based on the other condition. If the condition is true or if the condition is satisfied, here is from this the region, whatever the region now we have taken, whatever the critical other section or whatever the critical region we have taken in this the critical other region, once the process is completed, if it is satisfies the condition, if it is, that means if x is equals to 1, that is satisfies the other condition. If it is true, then execution is the completed means if it is true. If it is x is equals to 1, if execution is now which is the ongoing, that means if x is equals to 0, if it is a false. So this is the condition the variables. Here based on this the condition variables, now it might be used to signal the worker thread when a new connection is added to the list. And here is this is a code. This is a code for the mutual the exclusion. So that is a portable operating system interface now. That is a pthread to illustrate this concept now. So the declarative hash include pthread.h, hash include stdio.h, hash include stdlib.h. These three are the header files for the mutual other exclusion. So POSIX pthread implementation is a pthread POSIX portable operating system interface. So this is the portable the operating the system. This the interface now. With help of this the interface now effectively threaded mechanism can be implemented. Threaded mechanism is nothing but it is a single flow of other control. Single flow of control means that means if multiple other resources are sharing, so which are trying to share the same other resources. So from that now, which allow only one resources. That is a mutex. We can say it as the shared resources that are p thread mutex. The code is p thread mutex underscore the mutex p thread the conditional variables into shared the resources. If it is a 0, void thread the function void the arguments p thread the mutex log at the rate of the mutex while shared resources is 0. The shared the resources is 0 means here no resources are shareable to the other processes from the critical section. From the critical section for execution. Here is from this the critical section. So no resources are shareable. No resources are shareable means here shared resource is 0. Shared resource, so it is if it is 0, no resources are shareable. And p thread the condition weight, that is a condition variable at mutex. That means here next printf thread percentage using the shared resources, that is the long arguments. That means performing the operations on the shared resources. The shared the resources is 0. That means reset the resources. P thread the mutex unlock, that is ampersand of the mutex, so returns the null. Here is int main p thread threads to p thread mutex init mutual exclusion is arguments are mutual exclusion and null. P thread the condition initialization, that is the conditional variables. Now we are using the conditional variable which are null. These two are the conditional variable arguments. And here creating the threads. For creating threads, the code is for long I is equals to 0, I less than 2, I other plus plus. So which is the incremented. Here is the creating thread. The function for creating thread is p thread. The function for creating thread is a p thread which creates the thread of I. Null thread the function void star I. Here with the help of these the function, now we can create the threads. We can create the threads. So whatever the threads we have created, so that can be the process. Here the threads the processor, now the processing. That means the processor is the processing means here it can be associated with multiple threads. After creating the thread 1, thread 2, thread 3, thread the 4, thread the 5. Here whatever the threads now we have created, so these all the threads, all the other created other threads that can be associated with the processing. Here the processing means here performing the other task, completing the other task, and giving the well defined the effective output. That is a simulated work and signaling other threads. Now for that now we are using the sleeping method. And in this the sleeping method, now what we are doing, locking. Now we are locking the threads. Once if it is allocated, once the thread or the process is allocated to the critical section, so that can be locked. That can be locked up to completion of the process. So up to completion of the process. Once the process is completed in a critical section or in a critical region, so it will be the unlock. It will be unlocked. Here p thread the mutex lock at the rate of mutex. Now we are addressing the mutual the exclusion. Shared resources is equals to 1, and p thread the condition signaling. Signaling can be done based on the condition. The condition is if the variables, if the processes is in a critical region or not. Based on that, the availability of the processor now will give the conditions. That is pthread the mutex. Unlock mutex. That is unlocking the mutex. That means mutual exclusion. If it is, when it is unlocking this, the mutual exclusion means here, once the process is completed, now we can unlock the mutual the exclusion and giving the chance to another other process. Wait for the threads to completing. Here is for I is equals to 0, I less than 2, I plus plus. And p thread join threads null. That means p thread mutex destroy at the rate of the mutex, and p thread the conditional destroying the conditional variable and returning 0. Here this is a waiting for the thread to complete. The threads are waiting to the completing, and this is the code. This code is a simulating the work and signaling the threads for ready to execution. And this code now, whatever the code is written here, these are the code. With help of this other method, now we can creating the threads. So by creating this other threads now, single flow of execution can be done in a critical section or in a critical region. Here is in this whatever this now the code is discussed, we have now these two threads which are the wait on a conditional variables until the main thread signals they share the resources is ready for use. Each thread then performs the operations on a shared resources in a single threaded shareful manner. And real-time applications. The real-time applications are these the mutex and conditional variables in a advanced socket programming. Now we are using in a network servers. Network servers means here that is a web server or database server. Web server, now if we take the web server, this web server handling the multiple clients request simultaneously. Here if we take this web server, now this the web server now which is handling the multiple other clients at a time. That means the synchronization mechanism. We can implement that means the concurrency the concept of now we can implement. That is a client 1 and client the 2, client the 2 and client the 3, client 3. That multiple other clients can be executed at a time with help of the web the servers. That means mutual exclusion. For that now what we are doing, that the mutual exclusion, that is a mutex now which is ensures the safe access to shares the resources such as a log files connection list, that is a log files connection list or a configuration data and the condition variables that can be signaling the threads, signaling the working other threads and non-working other threads. Non-working threads means now whatever the threads in a waiting state, so the waiting state of the threads now we can call it as a non-working other state. The signaling threads now which is ready to process, now we can say it is a working threads. The new clients now requests are available. Here is the database of the servers. Database of the servers are synchronizing the access to share the database of the connections or querying the results. So this is a database of the servers. Now networking server, these two are now we can say it as a networking servers. Embedded systems. Embedded systems are the real-time operating system and automotive other systems. So real-time operating system and automotive systems now can say. So managing real-time operating systems now which is managing the task with a strict timing request, and mutual exclusions and conditional variables now which is helping the coordinating task. Coordinating the task one by one task will be the coordinated, and ensuring that the critical section of the code are not accessed by the multiple other tasks simultaneously. Here is automotive systems. So with help of this, the automotive system, what we are doing now, we can handle the various the sensors or control systems in a vehicle. The best the example, the automotive system is a, that is gear. Without gears, automatic cars now. So in the automatic cars, the automotive or the systems will be arranged which handle the various the sensoring systems and controlling. That is another best example is the metro trains are the automotive or the systems. The sensoring systems and controlling systems can be arranged in a metro rail. Here is which ensuring the data consistency between the sensor readings and the control algorithms. Telecommunication systems. Telecommunication systems means voice over IP servers. Voice over IP servers now, which is managing the multiple voice streaming. Multiple voice the streaming. That means the number of other voice signals can be managed with help of these other servers and handling the multiple other signals and performing the other task and responding whatever the other signals are received by the other server. So process will be completed and responded to the client. Whatever the client is asking and responded to that other particular other client, and which is ensuring the real time other processing. So mutex that is a mutual exclusion. This is the mutual exclusion which allows the only one process. Here the mutex now mutex which allowing, so mutex is nothing but a mutual exclusion. In this mutual exclusion, with help of this the critical section, we can allow only one process and executing that other process within this the critical region and protect the access to share the buffers. While condition variables and signaling when the data is available for the processing. Base station controllers. Base station controllers means here. So these are the base station controller which the coordinating the communication between the mobile devices and the network the infrastructure. Here the best the example is a mobile communication. So in this the mobile communication, so the data cannot be transferred to the user 1 to user other 2. The data cannot be directly communicated to the user 1 to user 2. First, the data can be transferred to the base station, that is a server station. From that the base station, that will be sent to the user other 2. It will be happen within a fraction of seconds. So that is a base station with help of this base station controller. So that can be done. Here, multimedia applications, streaming services. So multimedia, the applications that means now which is handling the concurrent streamings of the audio video data. That means it is a mutex which ensures that the streamings are very synchronized. That is the data flow, the flowing of the data. That means now if you are communicating from user 1 to the user 2, the data now we are transferring the data. Here we are transferring the message. For example, if you are sending the hello or the message, that will be reaches to the destination within a fraction of seconds with help of the base other stations. And condition variables now, where they apply the condition variables. When you can transmit the user to whenever the channel is available. At a base station, whenever the signaling channel is available, then only we can transmit to the user 2. Here, based on some conditional variable, the signals can be utilized when the data packets are ready for encoding and decoding. Encoding and decoding. Gaming servers here, which is managing the multiple player connections and a game, state the update in a real time the applications. That is a gaming or the server. And the objectives of the mutex in a advanced the circuit programming are mutex the exclusions, data integrity, thread the synchronization, objective of the condition variables in a advanced circuit programming, thread the communication, blocking and signaling, efficient resource management. So these are the main objectives of the advanced the socket in the programming. Here is mutual exclusion, which ensures that only one thread can be accessed. A critical section. Critical section, it is nothing but it is an executable area or it is an executable environment. Whatever the other process, whatever the job now we are assigned to the critical other section. In this other critical section, the process or job can be completed. Up to that completion of that job, these are the critical section which won't allow the another other process or shared resources at any given time. Any given time, that means any given time means up to whatever the time is allotted to the critical section, up to that now the process will be executed. So after completing that now the resources will be the shared. And preventing the data race, that means data race means the multiple other tasks, multiple other processes which is asking to the critical section for execution. But here this mutex mutual other exclusion now which is not allowed the multiple other process to entering into the critical section for executing the task and ensuring the other consistency. Now ensuring consistency means whatever the data, whatever the process is completed, so that will be stored in a database. So with help of this other process or with help of this other data, now we can take the other decision. We can make the other decisions. The correct other decisions can be made by the other programmer and execute the other process. Here is data integrity. Data integrity that means protect the shared data structures such as the connection queues, buffers and state the information from the concurrent actions which ensuring their consistency and correct state. Consistency and correct the state. That means the information, whatever the information you have stored, it is correct. So with this the information we can take the decisions, effective decisions can be taken. Third, the synchronization. The synchronization means here the coordinate the execution of the threads. Whatever the threads now we are executing in a critical other region, so that will be the coordinated. So multiple other threads now we can't able to execute. One by one thread can be executed. Why? Because this is a capability. So this is the feature of the critical other region. Now, by ensuring that the operations on a shared resources which will be performed in a safe and orderly manner. Here is the objectives of the condition variables in a advanced the socket of the programming. So that is a thread of the communications. So this is the thread of the communication now which is enabling the thread single the flow of the control to signaling each other. So about the availability of the resources or the occurrences of the event now which is facilitating the effective inter-thread the communication. Here blocking and signaling, efficient resource management. So these are all the objectives. So and now the outcome of the mutex and the conditional variable are. So this is the outcome of the mutex and conditional variable. The mutex which ensure the thread safe access. Whatever the threads we are executing, whatever the threads we are running, that will be safe. Why? Because to share the resources or preventing the data races and maintaining the data integrity. And condition variables now which is enabling efficient thread communication and synchronization. That means efficient the thread the communication and synchronization at a time we are performing the task and reducing the CPU usage and improving the resource management. So these are all the outcome of the mutex and conditional variables, and these are all the textbooks, Unix network the programming, network the management, and reference book or the internet networking with the TCP/IP and web other references. Or these are all the web references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.